Hi all of you. Welcome to another lecture of antenna and wave propagation. The topic for discussion today is radio wave propagation. Myself Maria Joseph, Assistant Professor in Electronics and Communication Engineering Department of MBC CTP Debate, leading the session. This is the topic in Module 6 of KTU syllabus. The first topic in Module 6, radio wave propagation. What do you mean by radio wave propagation? The radio waves propagate from an antenna. The speed of light is same as that of the speed of radio waves. The exact nature of these waves is determined by the transmission medium, the way in which they are transmitted. In atmosphere, they travel in curved paths. These waves are reflected and refracted in a manner similar to light. Electromagnetic waves are basically transverse in nature. This is the basic structure of electromagnetic waves. That is, the electric fields are represented in the x-axis and magnetic field is represented in the z-axis, and this is the y-axis, x, y and z. So you have the red one is the traveling direction, and you have the electric field, then you have the magnetic field as shown in the figure. Now, there are different frequency of signals in which they propagate. That is, we have very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency and super high frequency. All this different frequency of signals will determine which type of propagation we should choose. There are basically three modes of propagation which we'll see now. The different modes of propagation. One is the ground waves, the other one is space wave propagation or line of sight propagation. The third one is the sky waves. So these much frequencies belongs to very low, low and medium belongs to ground waves. The application submarine communications, AM, FM and television broadcasting. The space wave propagation is used for these frequencies. The applications satellite communication and mobile communication, and the sky waves basically used for microwave links and radar communications. Ground wave propagation. This is the image representing the ground wave propagation. Ground wave propagation is a method of radio wave propagation that uses the area between the surface of the earth and ionosphere for transmission. Ionosphere is something in the atmosphere. Okay. The ground wave can propagate a considerable distance over Earth's surface, particularly in the low frequency and medium frequency portion of the radio spectrum. We saw that in the radio spectrum. The ground wave radio signal propagation is ideal for relatively short distance propagation on these frequencies during the daytime. Sky wave or ionospheric propagation is not possible during the day because of the attenuation of the signals on these frequencies caused by the D region in the ionosphere. We will see the different layers of atmosphere. In view of this, the lower frequency radio communication stations need to rely on the ground wave propagation to achieve the coverage. The effect of ground in the ground wave propagation. The surface wave is very dependent upon the nature of ground over which the signal travels. Ground conductivity, terrain roughness and the dielectric constant all affect the signal attenuation. In addition to this, the ground penetration varies, becoming greater at lower frequencies, and this means that it is not just the surface conductivity that is of the interest. At the higher frequencies, this is not of great importance, but at lower frequencies, penetration means that the ground strata down to 100 meters may have an effect. That is, basically, there is an effect for the ground in the ground wave propagation. These are the factors which determines the ground wave propagation. The another type of propagation is the space wave propagation. The direct ray is there, the ground reflected ray is there, you have the tangent line. This is HR, HR dash, this is HT and HT dash. Here we have ht dash and h dash are the effective heights of the antenna, and the actual heights of the antenna is represented by ht and hr. Space wave propagation is defined for the radio waves that occur within 20 km of the atmosphere, that is the troposphere, comprising of a direct and reflected waves. These waves are also known as the tropospheric propagation, as they can travel directly from Earth's surface to the tropospheric surface of the Earth. It is also known as line of sight propagation, as the signals are sent in a straight line from the transmitter to the receiver. In order to prevent attenuation and the loss of signal strength, the heights of the antennas and the distance can be given as dm is equal to 2rht the whole raised to 1 by 2 plus 2r hr the whole raised to minus 1 by 2, where dm is the distance between the two antennas, r is the radius of the earth, ht is the height of transmission antenna, and hr is the receiver antenna. Next type of propagation is the skywave propagation, that is, you send the signals, it reaches the ionosphere and comes back. This is a type of propagation is called skywave propagation. In radio communication, skywave or the skip refers to the propagation of radio waves reflected or refracted back towards Earth from the ionosphere, an electrically charged layer of the upper atmosphere. Since it is not limited by the curvature of Earth, the skywave propagation can be used to communicate beyond the horizon at intercontinental distances. It is the mostly used in shortwave frequency bands. Now, just a mere comparison with the other type of propagations. Ground wave propagation, where the radio waves travel along the Earth's surface without being reflected or refracted by the atmosphere, the dominant propagation mode at lower frequencies. The ground wave propagation, where the radio wave propagation occurs along the Earth's surface. Okay. In the line of sight propagation, in which radio waves travel in a straight line, the dominant mode at higher frequencies compared to that of the ionosphere. Thank you.